Hi guys, this is my first chapter review video for the Barron's book. Chapter 1 is called Introductory Java Language Features, and the first concept discussed is packages and classes. Classes are grouped into packages, and that allows you to use them in other programs. Java programs have to contain at least one class, and that should contain the main method. All program statements must be contained inside a method. The next topic is types and identifiers. An identifier is the name for a variable, parameter, constant, user-defined method, or user-defined class. They can be letters, digits, and the underscore symbol. They cannot begin with a number and are case-sensitive. The primitive types in the AP Java subset are int, boolean, and double. Int means integer and can store any integer value. Boolean is used to store true or false, and double can store decimals. Hexadecimals use the base 19 and are represented with numbers 0 to 9 and letters A to F. A means 10 and F represents 15. Octal numbers use the base 8 and are represented with the numbers 0 through 7. It's useful to use these forms because they're concise, especially compared to their binary forms. Final variables use the keyword final before declaring a variable, and it means the value of that variable cannot change. The next concept in this chapter is operators. The first kind of operator is arithmetic, which includes a plus to indicate addition, a minus to indicate subtraction, an asterisk to indicate multiplication, a backslash to indicate division, and a percent sign to indicate the remainder between two numbers. The next kind of operator is relational operators. The double equal sign is used to see if two values are equal, and the exclamation equal is used to see if something is not equal. The greater than sees if one value is greater than another, the less than sees if one value is less than another, the greater than or equal to sees if one value is either greater than or equal to another value, and the less than or equal to sees if one value is less than or equal to another value. The next type of operator is logical operators. These operators are used to compare and evaluate Boolean expressions. The exclamation represents not, so if you compare two values to see if they are equal and put the symbol next to the double equal sign, it will return false if they are equal and true if they are not equal. The two and symbols mean that the Boolean expression on both sides must be true in order for the entire expression to be true. The two lines mean or, so at least one of the two expressions must be true for it to evaluate as true. The next type of operator is assignment operators. If you put an arithmetic operator in front of an equal sign, it does the operation between the two values and stores that value. The next type is increment and decrement operators. It is denoted by a double plus or a double minus sign after a variable. The plus plus increment operator adds 1 to the variable, while the minus minus decrement operator subtracts 1 from the variable. The output of a code is produced by writing either systemoutprint or systemout.println. The only difference is that system.out.println writes the next output on a separate line. Escape sequences are useful when printing. \n prints on a new line, \_ quotes prints out quotations, and two backslashes print out one backslash. The next topic is control structures. Decision-making control structures include if, and else statements. If the Boolean expression contained in the if statement is true, you execute the if statement, but if it is false, you go on to the else if statement. If this is true, you execute the else if statement, but if it is false, you go on to the else statement and execute it. You can have if statements nested in each other as well. However, you must be wary about which if statement the else statement is attached to. The three control structures that instruct the computer to perform its iterations are for, while, and do-while loop. The general form of the for loop is the initialization of the variable, the termination condition, and the update statement for the variable. The while loop just has a Boolean expression in its condition, and the loop keeps on running as long as that condition is true. The last major concept in this chapter is errors and exceptions. An exception is an error condition that occurs during the execution of a Java program. Examples of exceptions are the arithmetic exception, null pointer exception, class cast exception, array index out of bounds exception, index out of bounds exception, and illegal argument exception. We haven't gone over many of these, however, they come up in the later chapters. So now we're going to go on to the multiple choice for chapter 1. The first question is asking, which declaration will cause an error message? So we have to look at each implementation. First, they cast x as a double and y as an integer. So you're not able to set an integer equal to a double, so this would cause an error. But they're looking for which declaration will cause an error message, so this is the answer they're looking for. The next one declares x as a double and y as an int, but they cast x as an int when they set it equal to y. So x now becomes an integer value, so you can set int y equal to x cast as an int. So this would be good, and it's not one of the answers they're looking for. So the third one, they say that x is an int, and y is a double value. And a double value is able to be set equal to an integer value, so this wouldn't cause an error. So the answer would be B. For the next question, they ask you for what the output will be. The double backslash indicates that one backslash will be printed. So it prints one backslash, one asterisk, and it says this is not, but they have an N here, and that's one of the escape sequences. So it would go to a new line, and it would continue printing. And it would end with an asterisk and one backslash. So the only option that has this is E. For number 3, they ask you to evaluate what happens in the code segment. So they tell you that n has a value of 0. So in the first if statement, they say that n cannot be equal to 0. And since this is an and, it means that both of these things have to be true. So since one is not true, it wouldn't evaluate statement 1. It would go straight to the else statement. So the answer would be D, because statement 2 would be executed, but not statement 1, because n is equal to 0. So in number 4, they give you a fragment of a code, and they have a problem in the code that they want you to fix. However, the question is asking which code will not fix it, but we can go through the answers and eliminate the ones that do fix the problem. They want the output to be 2.6, but it gave them 2. So they had trouble casting the variable in this line. A properly casts 13 divided by 5, so that would give you the output of 2.6, so that's not the answer they're looking for. And the same thing with B, they cast it correctly because they casted one of the integers. With C, 5 is declared as a variable, and with D, 13 is declared as a variable, so C and D both wouldn't work, leaving you with answer E. They incorrectly casted 13 divided by 5. There aren't supposed to be parentheses on either side. For number 5, they ask you to evaluate a result. So multiplication, division, and mod all have the same precedence over subtraction, so you would leave the subtraction for last. You would instead do the multiplication since it goes from left to right. After the multiplication, you would divide, and then you would do the mod, leaving you with a result of 12. For number 6, they ask you to reverse the order of precedence, which means that addition and subtraction have higher precedence than multiplication and division. So instead of starting with multiplication and division, you would add the 2 and 3 to leave you with 5 times 12 divided by 3, because you would do the subtraction, plus 8. And then you would further evaluate that to get 5 times 12 divided by 11. And since you go left to right, you would get 60 divided by 11, which would evaluate to 5. So the answer would be C. For number 7, they're asking you to evaluate the Boolean expression. So for this problem, you have to go through all the cases of x. So since x would actually cancel out, it would be easy to say that the 3 just equals the 3 on this side, but you have to think about all the cases. So if x equals 0, then this would be undefined, and 3 would not equal undefined. So the correct answer would be C, since it'll only evaluate to false when x is 0. Number 8 is asking you about things from the math class. So they say that math power x 0.5 equals to math square root of x, even though x to the 1/2 is equivalent to root x. So what they're saying here is that this equals this, which is true. However, they don't round to the same values, which is why D would be the correct answer, since there is a round-off error calculating the power and square root functions. In number 9, they give you a code segment and tell you that num equals 22. So you just have to run through it. Since 22 is greater than 0, you do the next if statement, and 22 mod 5 does not equal 0. So you don't do this statement, you go straight to the else statement, and you print this out. So it prints out 22 is negative, which is option D. For number 10, it gives you a code segment, and you have to run through it with the values that they give. So they say that x equals 30 and y equals 40. So if x is greater than or equal to 0, that's true. You go to the next if statement. If 30 is less than or equal to 100, so that's true, you move on. Y equals x times 3, so it would equal 90. So now if y is less than 50, y is not less than 50, so you would skip this, and you already evaluated this if statement, and this if statement connects to this else statement, so you wouldn't complete that. And you also wouldn't complete this one because you already evaluated this if statement. So the final value of y would be 90, and the final value of x would still be 30. And the option that gives you that is option A. So for number 11, they give you Boolean statements, and they ask you which will evaluate to true only if Boolean expressions A, B, and C are all false. So the key here is all false. They will all return true if all of them are false, but not all of them need to be false for some of the answer choices. So for A, B or C can either be true or false according to this statement, so it wouldn't be A. For B, A, B, and C don't all have to be false, which eliminates B. And for C, they actually all have to be false. And it's because of the not out here. Because this expression has to evaluate to false, because this will make it true. So the correct answer is actually C, but we'll keep going through the answers. For D and E, it's the same reason as B and A. They don't all have to be false for this to evaluate to be true. So the correct answer is C.